Hello everyone, welcome to the video on beta-lactamase inhibitors and monobactams medicinal chemistry details. In this video, I will explain about beta-lactam inhibitors like Clavulanic Acid, Sulbactam and Tazobactam and monobactam drug Aztreonam details. This is my YouTube channel. If you like the video content, do subscribe and share. Let's get into the topic. Now, beta-lactamase inhibitors, all of them has got a common pattern of mechanism of action. Normally, the beta-lactam antibiotics like penicillins, cephalosporins, all of them, they inhibit bacterial cell wall synthesis. When the cell wall synthesis is inhibited, bacteria is killed. This is what is the mechanism of action of all these beta-lactam antibiotics. Now, the resistant bacteria, what it does is, it synthesizes beta-lactamase enzyme. This enzyme will break down this beta-lactam ring. If beta-lactam ring breaks down, it cannot show its mechanism of action. Now here comes the mechanism of action of beta-lactamase inhibitors. These inhibitors selectively inhibit beta-lactamase enzyme that is secreted by this bacteria. This beta-lactamase also known as penicillinase. So this enzyme is inhibited. Remember, beta-lactam inhibitors, their function is only to inhibit this enzyme. As such, they do have less potent antibacterial activity, but it cannot be used to treat bacterial infections. Its job is only to inhibit beta-lactamase enzyme. Now, in detail, see, this is what is beta-lactamase enzyme produced by bacteria. When this beta-lactam is there, it acts on beta-lactam antibiotics like penicillin and cephalosporins and it breaks down the nucleus. So, when it is broken down, it cannot bind with penicillin binding proteins. Understand this word. Penicillin binding proteins are enzymes which are essential for bacterial survival. One of the major enzymes is transpeptidase. The job of this transpeptidase is to make this cross-linking in the cell wall. And these cross-linkings are inhibited when this beta-lactam antibiotic binds with this transpeptidase enzyme. So this is how it acts. So when beta-lactamase enzyme is there, it inhibits beta-lactam ring and beta-lactam is no longer shows its activity and bacteria is stable. But when you use beta-lactamase inhibitor, it goes and binds with beta-lactamase enzyme of bacteria and beta-lactamase is inhibited. When this enzyme is inhibited, antibiotic can show its activity. It goes and breaks this cross-linking of cell wall and that results in bacterial cell death. So usually beta-lactamase inhibitors are used along with this beta-lactam antibiotics like penicillins or cephalosporins are used along with beta-lactamase inhibitors. Now, selective drugs, you have clavulanic acid is there. Now look at the drug structure. See, it has got a beta-lactam ring. See, at the beginning of the classes, I told you the moment you see this beta-lactam ring, which is a pharmacophore, it will exhibit antibiotic activity. So this drug has got a weak but unimportant antibacterial activity is there. Now, in penicillins and cephalosporins, you have a sulfur containing 5-membered ring is present in penicillins. Sulfur containing 6-membered ring is present in cephalosporins. But in case of beta-lactamase inhibitors, you have oxazolidine ring, oxygen containing ring is there. So again, it is a bicyclic fused ring system. Beta-lactam ring is fused with oxazolidine ring. Now let us understand IUPAC name. Now look at them. What all the things are there here? See, I have explained this already. When you explain about IUPAC name, it has to start with stereo centers. First you need to mention about stereo centers. Now where do you have these stereo centers? See, at second position this is a stereo center and then at fifth position this is a stereo center. Now this one shows geometric isomerism and that geometric isomerism belongs to Z1. So initially you need to explain about stereo centers. Second position and fifth position R conformation is there and this geometric isomerism is known as Z configuration. Now see, geometric isomerisms can be in two different configurations, E and Z. When two of the high priority groups are present on the opposite sides of the double bond, it is known as E configuration, entagon. Whereas when two of the configurations are present on the or high priority groups are present on the same side, it is called as Z configuration. Now here at this double bond, the OH and oxazole ring oxygen are present on both sides, hence it is known as Z configuration. They are derived from Greek words entagagon and zumezan. Entagagon means opposite side high priority groups. Zumezan means same side high priority groups. So this Z configuration talks about the double bond high priority group orientation. Now after that, look at this. At third position, 1, 2, 3, at third position you have a 2-hydroxy ethylidene group is there. See, this is 2-hydroxy and this one is ethylidene group. And at 7th position, oxo substitution is there. Now the ring is 4-oxa, 1-aza bicyclo, 3-2-0. Heptane 7 atoms make this ring and 2-carboxylic acid. At second position, carboxylic acid is there. I have explained about this IUPAC in detail in penicillin video. Please go through it. Let me revise this. So the IUPAC name at second, fifth position, you have stereocenters are there. You need to explain about confirmation about that. Now at this position, both the bulky groups are on the same side, hence the Z configuration will come. Now at third position, 2-hydroxyethylidene group is there, and at seventh position, oxo is there. The ring is 4-oxa, 1-aza bicycloring, 3-0 heptane, and second position carboxylic acid is there. Now look at the important features of this drug. So it has got a weak but unimportant antibacterial activity. It is a powerful irreversible inhibitors of beta-lactamase. They are known as suicide substrate. They go bind with the enzyme and they inhibit the function of that enzyme, and it's a kind of committing suicide. They go bind with the enzyme, they themselves will break down, but the enzyme is irreversibly inactivated. Now used as a sentry drug with ampicillin. Usually these drugs are used along with ampicillin and amoxicillin. The popular preparation is augmentin, a combination of amoxicillin and clavulanic acid. Now so it allows less amoxicillin per dose and increased activity spectrum. So it enhances the activity of amoxicillin. Now there is one more combination timentin, which is ticagrelin with clavulanic acid. So this is about beta-lactamase inhibitors. Now the other things, see the other drugs are Sulbactam and Tazobactam. Now both of them sulfone derivatives. You can see in the structure they have got sulfone is there. Though the heterocyclic ring contains sulfur atom, it is in the derivative of sulfone. In case of Tazobactam, it is a triazine derivative. See, these drugs, they are suicide substrates for beta-lactamase enzymes, but Sulbactam has got a broader spectrum of activity. It means it is effective against gram-positive, gram-negative, wide variety of bacteria to show antibacterial activity, but it is less potent. So it cannot be used as an antibacterial agent, but it can only be used along with antibiotics. Now there is a combination called ampicillin and Sulbactam unacin. Tazobactam also has got broad spectrum versus beta-lactamase than clavulanic acid and has got similar potency. Again the combination is tazocin, piperacillin, Tazobactam. So the important things are you need to understand the mechanism of action and structural aspects. So these are about beta-lactamase inhibitors. Now see, beta-lactamase inhibitors are used along with penicillins and cephalosporins. Now the combinations amoxicillin, clavulanate, ampicillin, Sulbactam, both of them can be used orally, whereas piperacillin, Tazobactam can be used intramuscularly as well as intravenously. Now the other combination, ceftazidime, is used along with avibactam. Avibactam is novel beta-lactamase inhibitor. Now ceftolozane, Tazobactam, all these combinations are used. They can be used orally, intramuscularly, intravenously. So this is about beta-lactamase inhibitors. Now the next part is monobactams. This is also a beta-lactam antibiotic. Mono means a single beta-lactam is there. Beta-lactam ring is there, hence they are called as monobactam. In case of penicillins and cephalosporins, the beta-lactam ring is fused with a 5-membered heterocycle or 6-membered heterocycle. But in case of monobactams, only heterocyclic ring is there without fusing without any other ring. Now there are certain unique features are there, like it is a totally synthetic antibiotic. It can be used only parenterally, orally ineffective, and it exclusively acts against gram-negative, so narrow spectrum antibiotic. Inactivates some of the beta-lactamases. As such, it has got this beta-lactamase inhibiting activity, but the drug is unchanged in metabolism. You can see it has got a lot of polaric groups, hence it is unchanged, goes out of the body as such. Now clinical uses, as I told you, it acts only against gram-negative, and especially it is used to treat infection acquired in hospitals. They are known as nosocomial infections like urinary tract infection, upper respiratory tract, bone and cartilage, abdominal and gynecological infections, and septicemias. So this is what is the major clinical uses of Aztreonam. So these are about beta lactamase inhibitors and monobactams. If you like the video, do subscribe and share. Thank you for watching this video.